All trunk interfaces went down for 15 minutes. The culprit? IOS command blindly reapplying vlan 100 every 5 minutes. Let's break down Ansible Network Automation, how it works, and the exact mistake behind that failure. Ansible Network Automation allows you to manage network devices using the same declarative model as servers. The core connection plugin is Network-CLI, which manages persistent SSH connections and handles privilege escalation. Vendor-specific modules like iOS Config and Junos Config use this connection to push configurations idempotently. The Network-CLI connection plugin is the standard for SSH-based network automation. It maintains a single SSH connection for the entire playbook, reducing overhead, and handles privilege escalation automatically when you set Ansible Become and Ansible Become method. Here's a production setup for Network-CLI. Always set Ansible connection to Ansible, netcommon, Network-CLI, and specify the network OS. Use Ansible Vault for credentials and set Become for enable mode. The two most common Cisco IOS modules are iOS Command and iOS Config. iOS Command sends arbitrary CLI commands and is not idempotent. iOS Config reads the running config, compares it with the desired state, and applies only necessary changes. Always use iOS Config for configuration. This is the correct way to configure a VLAN. iOS Config will only apply the vlan 100 command if it's not already present under the interface, ensuring idempotency. This is the wrong approach. iOS Command sends the commands blindly, causing the switch to reapply vlan 100, which resets the interface and causes a flap. For multi-vendor environments, Ansible provides network-agnostic modules like CLI Config and CLI Command. These rely on the Ansible Network OS variable to determine the correct CLI syntax. They're great for simple tasks, but lack idempotency for complex configurations. This example uses CLI Config to set a hostname. It works across Cisco iOS, Junos, EOS, and NXOS as long as Ansible Network OS is set correctly. NAPALM provides a higher-level abstraction via the Community Network NAPALM modules. It uses APIs like NETCONF or ARISTCONF for operations that are more reliable than CLI scraping. It returns structured data and supports commit and rollback operations. This example gathers facts using NAPALM. The NAPALM GetFacts module returns structured JSON data, which is much easier to work with than CLI text output. Juniper Junos devices use a candidate config and commit model. The Junos config module handles this properly, supporting commit confirm and automatic rollback on error. Never use Junos command to send set commands directly. This example configures an interface on Junos. The Junos config module applies the changes to the candidate config and commits them. It only applies changes that differ from the current candidate config. Arista EOS is similar to Cisco iOS. The EOS config module is idempotent and compares the desired config with the running config. Make sure to set Ansible Become for enable mode. This example configures a VLAN on Arista EOS. The EOS config module ensures the VLAN is created only if it doesn't already exist. Cisco NXOS uses the NXOS config module. It's idempotent, but you must ensure required features are enabled before configuring related settings. For example, enable feature interface VLAN before configuring VLAN interfaces. This example configures a VLAN on an NXOS. The NXOS config module applies the changes idempotently. Idempotency is harder on network devices than servers. Config modules compare text, not structured data, so whitespace differences can cause false positives. Stateful commands like no shutdown have side effects. Always test with check and diff. This is an idempotent VLAN config. It will only create VLAN 100 if it doesn't exist. If it exists, no change is made. This is the same issue we highlighted at the start. Here's exactly why that happened. The playbook used iOS command to push the VLAN config. iOS command doesn't check current state, it sends the command verbatim. The switch interpreted vlan 100 as a create command even though the vlan existed, causing a momentary interface reset. This flapped all trunk ports. The root cause was using EOS command to push configuration commands, which does not check current state and reapplies commands every run, causing interface resets. The fix uses EOS config with lines and parents to compare and only apply if config differs. The fix is to use EOS config with lines and parents. EOS config reads the running config, compares it with the desired state, and only applies changes if needed. This prevents unnecessary interface resets and ensures idempotency. This is the mistake from the incident. Using EOS command for configuration changes causes the command to be sent every run, even if the config is already present. This can cause interface flaps and other issues. Always use EOS config for configuration. If you don't set Ansible connection to Ansible, NetCommon, Network-CLI, network modules will fail because they expect the Network-CLI connection plugin. Always set it explicitly. Network devices require enable mode for configuration commands. If you omit Ansible become and Ansible become method, the module will fail with a privilege escalation error. Always set Ansible become yes and Ansible become method enable. The Ansible NetCommon Network-CLI connection plugin requires Ansible 2.9 Plus and the Ansible NetCommon collection install via Ansible Galaxy Collection install Ansible NetCommon. In Ansible 2.8 and earlier, use connection Network-CLI without the FQCN, but this is deprecated. Always use the FQCN for future-proofing. The article mentions backup. Yes in error handling, but doesn't show how to use the backup path for rollback. Here's a concrete example that saves the backup and restores it on failure. The article warns that check may not work with all network modules. In practice, many vendor-specific config modules, e.g., EOS config, Junos config, do support check in recent versions, but CLI config and CLI command often do not. Always test check in a lab before relying on it, and consider using diff as a safer alternative for previewing changes. When debugging, start with verbose output using VVV. Check SSH connectivity from the control node. Use check and diff to preview changes without applying them. Enable logging in Ansible, CFG to capture detailed logs. Let's run through some common interview questions. What is the difference between EOS command and EOS config? EOS command sends CLI commands blindly. EOS config manages config idempotently. How do you achieve idempotency with Cisco IOS? Use EOS config with lines and parents, test with check and diff. What is Network-CLI and why is it preferred? Persistent SSH connection handles enable mode, more efficient than local. And a few frequently asked questions. What is the difference between Network-CLI and netconf? Network-CLI uses SSH and CLI, netconf uses NETCONF protocol, more reliable. Can I use EOS command for configuration? Technically yes, but it's not idempotent and can cause issues. Use EOS config instead. How do I test idempotency? Run the playbook twice. Second run should show changed equals 0. Use check and diff. Let's recap the key takeaways. Use Network-CLI for SSH-based automation. Use config modules, not command modules. Test with check and diff. Encrypt credentials with Ansible Vault. Ready to go deeper? Up next, Ansible tutorial for beginners, then Ansible v's Terraform. When to use each, then Ansible AWX and Tower Guide, and Ansible v's Chef versus Puppet versus SaltStack. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.